Welcome to my channel, Worldwise. This is gonna blow your mind. Time. It's what we measure our lives by. It's a constant, right? Maybe not. What if everything we think we know about time is wrong? What if time isn't a straight line from the past to the future, but something much more complex? We save time, waste time, and run out of time. But time doesn't care about our schedules or deadlines. It marches on, indifferent to our human experience. This brings us to a fascinating possibility: the illusion of time. Is time merely a construct of our minds, a way for us to organize our experiences? Let's dive into this intriguing concept and explore why our perception of time might be deceiving us. Imagine a timeline of human history stretching out before you. Now, try placing these significant events in chronological order: the building of the Great Pyramid of Giza, the life of Cleopatra, and the invention of the printing press. You might be surprised to learn that Cleopatra lived closer in time to the invention of the printing press than to the construction of the Great Pyramid. This throws a wrench into our linear understanding of time and history. We tend to group historical figures and events based on our perception of their era, but the actual timeline can be quite surprising and often counterintuitive. Let's consider another example: the extinction of the dinosaurs and the emergence of the first humans. The dinosaurs disappeared from Earth around 66 million years ago, a staggering amount of time. Our early human ancestors first appeared around 2 million years ago, much more recently. That means there's a larger gap of time between the dinosaurs and humans than between humans and the pyramids. These examples highlight how our brains can distort the perception of time intervals, making history seem more linear than it truly is. Our brains aren't perfect timekeepers. They often play tricks on us. They rely on memory, perception, and context to make sense of time's passing, which can be quite subjective. This can lead to the chronological illusion of time, where our perception of duration differs from the actual time elapsed, creating a fascinating discrepancy. Think about a time when you were bored. Did it feel like time was moving incredibly slowly, almost dragging on? Now think about a time when you were fully engaged and having fun. Did time seem to fly by almost too quickly? This is because our brains tend to compress familiar and repetitive experiences, making them feel shorter and less significant. On the other hand, novel and stimulating experiences capture our attention, making time feel more expansive and memorable. Studies have shown that repetition can actually alter our perception of time, making it seem to stretch or contract. In one experiment, participants who were repeatedly shown a brief flash of light perceived the light as lasting longer than those who saw it for the first time, highlighting the brain's role in time perception. Section 4. Ancient Clocks and Modern Marvels: A History of Timekeeping. Throughout history, humans have sought to measure and track time. The earliest timekeeping devices were rudimentary, relying on the movement of the sun and stars. Ancient Egyptians used sundials to divide the day into hours, while other civilizations developed water clocks and hourglasses. The invention of the mechanical clock in the 14th century revolutionized timekeeping, allowing for more precise measurement. The development of quartz clocks in the 20th century further increased accuracy, and today, atomic clocks provide the most precise timekeeping available. As our technology advanced, so too did our understanding of time. We began to realize that time wasn't absolute but relative. Section 5. Time warps and relative relations. In the early 20th century, Albert Einstein's groundbreaking theory of relativity shattered our Newtonian view of time as a constant, unchanging entity. Einstein proposed that time is not absolute, but is relative to the observer's frame of reference, meaning it can vary depending on speed and gravity. Imagine two clocks, one on Earth and one traveling at high speed through space, like on a spaceship or a fast-moving satellite. According to Einstein, time would actually pass slower for the clock in motion relative to the clock on Earth, a phenomenon known as time dilation. This phenomenon, known as time dilation, has been experimentally verified through various scientific experiments and observations. Relativity also introduced the concept of space-time, a four-dimensional fabric woven from the three dimensions of space and one of time, fundamentally altering our understanding of the universe. This mind-bending idea suggests that time and space are inextricably linked and can be warped and curved by gravity, affecting everything from light to the passage of time itself. These concepts are difficult to grasp, but they highlight the limitations of our everyday understanding of time and challenge us to think beyond our usual perceptions. Time is not a simple linear progression, but a complex and dynamic phenomenon influenced by factors we are only beginning to understand, such as speed, gravity, and the very fabric of space-time. Section 6. Time. A line or a circle. So what is time really? Is it an illusion, a dimension, a river, or something else entirely? We're still searching for answers. Perhaps time isn't a line stretching from the past to the future, but a circle, constantly repeating itself. Maybe our past, present, and future are all happening simultaneously, and our linear perception of time is just a product of our limited human consciousness. The nature of time remains one of the greatest mysteries of the universe. As we continue to explore the cosmos and delve deeper into the quantum realm, we may uncover even more mind-boggling truths about the nature of time and its role in our existence. My next video is waiting for you. Watch it now.